Okay, part 2 of the open hour starting at 4:40 to 5. Okay, David, what's your question?
I think I just have like trouble like uh, when it's linear, and well, I'll show you.
Okay.
Like for example,
Cool.
no.
Yeah.
Can you see it?
Which
Wait.
one? The
Oh,
COS?
yes, that
Okay.
one. So yeah, I said that it is linear because it's oxygen, carbon, and sulfur,
Yep.
and then two of I don't know if you see it.
Yep. Yep, you got it.
So
That's linear.
is a linear.
Yep.
That my confusing part is when they go like this, and when it's like
Right.
actual linear.
So what has to be on the central atom for it to be bent?
Does it have to be equal bonding?
So you've got, so let me show you. Can I share my screen?
Yeah.
I'm going to share. Okay. So we've got this chart here. So here is linear, right? Central atom with 2 bonded atoms and no lone pairs, right?
No. Okay.
And then the question was, what has to be on the central atom for it
Yeah.
to be bent? What has to be there for it to bend?
The how do you call
Yeah. What's that called? The 2 dots?
octocks? No.
Okay, look. So we've got one of these, right? One of that, what we're trying to name. And then that one of those is up here. What's it called?
Lone pairs.
Yeah, exactly. And let me show you online. So what we're going to be using in lab, and I'll be showing you this then too, is we're going to be using these molecular shapes. So since you're not in person, I usually make you use the model kits to build the molecules, but we're going to do it online instead. So we've got these models here. And so this is linear, right, with just 2 atoms bonded, 1, 2, bonded to the central atom. But as soon as we put a lone pair on there, boom, right, that's where we see the bent shape, right? No lone pair, linear, add a lone pair, bent. Did I lose you? You still there?
Yes.
Okay. I know, it says my internet connection is unstable. So did that help? Do you see the difference there?
Yeah. Also, I have another example here, similar which probably gonna clarify better. I have sulfur and oxygen too.
Which one? Say it again.
Sulfur.
Yeah.
And oxygen too.
SO2, right. Sulfur
SO2,
dioxide,
yes.
yep.
Yeah. So I
Show what you have, yeah. A little closer. Can you move it like, okay, that looks, yeah, that looks just fine. Yep. So one thing, yeah, so trigonoplanar, let's look back on the model over here. Let's look back at the chart. So I'm going to show you share screen.
yeah.
I'm going to show you the chart again. So you want to use this too, which you'll be using in lab. But so you said that there were how many bonded atoms there and how many lone pairs on the sulfur?
two and two.
How many lone pairs are just on the sulfur?
Oh, two. Oh wait, so one.
Right,
Because
right. One
two,
pair,
yeah,
yeah, exactly.
two is one.
Right. So then we're looking in this column here, so the molecular geometry column here. So what do we call that molecular geometry when there's two bonded atoms in one lone pair?
Bent
Yep, which bent?
120.
Yeah, bent 120.
Okay.
You were right that the electron geometry is trigonal planar, but we're only looking in this lab for molecular geometry.
Okay.
Cool. So we'll go over more of that in lab. Okay, we'll get to more of those.
Are we supposed to are we doing this as
Yeah, that's actually in lab. Yeah, we're doing that in lab. You don't
oh,
have to do it
okay.
before lab.
Okay, because I almost I
Yeah.
almost finished.
So you're definitely ahead of the game. So you'll just bring it with you. Yeah.
Yeah, okay.
Okay.
That's good.
You're welcome.
What
What else? Hold on. So anyone else? Someone else's turn if you have a question.
for the quiz. And so for the quiz, I don't know if someone else has another question.
Does anyone want to pipe in? Or we can ask a question about the quiz. That's fine. 1, 2, 3, 4, 5, 6, 7, 8. Okay, what is it?
Can you give me an I don't know. Oh no, maybe not. Like I don't know what we. I barely look at the study guide.
Okay.
I look at the key.
Yeah, from last semester.
Yeah. So I know we're gonna do a Lewis structure.
Yep.
And are we gonna say if it's polar?
Yeah, let's see. I know we just went over that today, but I'd love to keep on track as much as possible since I know we're going to be like late, like no matter what with the online stuff. So I know we just covered that today, but let's go to the I'm going to share my screen and go to the study guide and make sure that it's in there. So modules, so we're in week 8. So yeah, it's probably Lewis structures for any type of molecule.
So do we have to memorize the shapes?
Let's see. Yeah, I won't be giving you a chart for the shapes. So if it does say that you need to know the shape, then yeah, you'll need to know those. So lab will definitely be good practice. Do you have lab tomorrow or
Thursday?
Okay, so at least you've already done your lab, so like that's great practice. We're in week 8, so quiz. Okay, so quiz 5 study guide. Yeah, so yeah, there are 6 shapes and 3 electron geometries. And I mean, what I mean is, okay, there are 6 molecular geometries, so like shape of the molecule. There are 3 electron geometries, and so I think that's doable for sure. Let's see, so yeah, Lewis structures. So making sure you know how to draw them for polyatomic ions too, like we did for nitrate, nitrite, and then another couple ones are on there. Let's do one. So what was your key? What was on the key from last year? What was the molecule?
Nitrogen. Uh, nitrogen and oxygen 3 minus. Well,
NO,
3.
I think it's nitrite or nitrate. It's NO3 minus.
right, nitrate.
Nitrate.
Okay, so do you want to try to do one? Let's do like let's do nitrite. Can you do nitrite, NO2 minus? Can you draw the Lewis structure for nitrite?
Yep.
NO2 minus. So you should do it for these two. I'll start over. So NO2 minus and CO2. Draw the Lewis structure, determine the shape. Draw dipole arrows. I'm gonna edit this. I know it's not fair and we'll see what I want to feel like doing for the quiz, but like I really want you to be able to draw dipole vectors on the polar bonds. I'm realizing now that the study guide hasn't said that. Maybe that's why people aren't doing that so well. But I'm gonna change it and we'll see how I feel about putting that into the quiz. So, come on, internet. So here I'm including be able to draw dipole vectors on any polar bonds. Point the vector toward the more electronegative atom.
So Elizabeth, would the Lewis dot structure for nitrate look like? I don't know if you can see it.
Yeah, let me see. I'm gonna change my video. Oh yeah, I was just drawing up on the screen, but you can even see me because I was on share screen. Sorry. So Kelsey, that is not quite, because what about nitrogen in the middle? Is nitrogen complete with an octet?
Oh, right. So you would move one of the lone pairs from oxygen over?
Yes.
Okay.
So starting with Lewis structures of each of these.
You show us like a couple ways to do the structure, right?
Yeah, for nitrite, there's a
Or
reservoir.
nitrite.
There's resonance, exactly. Are you
Resonance.
talking about moving the lone pair to a bonding pair? Yeah.
Yeah.
Yeah, you can either take it from one oxygen or the other one. Just make sure that it's only one and not both. Right, like here's nitrogen, oxygen, and when you fill in everything, right, the valence electrons here were 5 plus 2 times 6, or 6 times 2,
Plus,
right, and this 1 right here is another 1, which means that there were 12, 17, 18 valence electrons. Right, did you get 18?
Yeah.
Mhm.
Yeah, so that's 18 right there, but nitrogen isn't happy, so that's when you mentioned taking a lone pair into a bonding pair, and it doesn't matter which side you take it from. It's symmetrical. So that's the Lewis structure for nitrite.
And then would its molecular geometry be bent 120?
Right,
Okay.
right. Molecular geometry is bent 120, right? Because when we draw like in perspective, remember that a lone pair takes up space. Right, a lone pair takes up space, it's a group, right? So the molecule itself, just the atom, so molecular geometry, is the shape of the atoms. Right, and the electron geometry is the shape of the atoms and lone pairs. That's hard to see, I'm sorry. Shape of atoms plus lone pairs.
So for this one, would it be trigonal planar?
Right, trigonal planar, and let me show you the chart again, right? Exactly. So in this case, we've got 2 bonded atoms to the central nitrogen and a lone pair, right? So the shape of the atoms, the molecular geometry, is bent with 120 because that's the angle, right? It's, you know, the angle is less than 120, but it's close. And the electron geometry, however, is trigonal planar. So it's the same, right? Because this, or rather, it's still got 3 groups, and when 3 groups are attached, whether they are atoms or lone pairs, we see a trigonal planar flat shape, right? But yeah, it's called trigonal planar for the electron geometry because there's still 3 groups attached. And so yeah, so for yeah, so for this one, it is, yeah, molecular, bent 120. Electron, trigonal planar. And carbon dioxide, what about carbon dioxide? And so actually now the next question is this molecule polar? Can we draw dipole vectors on the nitrogen-oxygen bonds?
So nitrogen would be pulling in all the electrons from oxygens.
Which one is more electronegative? Do we have enough of a difference between electronegativities to call those polar bonds?
Oh, it would be oxygen.
Right. We do
Okay.
have enough of a difference. Nitrogen's 3.0, oxygen's 3.5. So that difference is 0.5, which does count as a polar bond. And
Okay.
oxygen is more electronegative. So we can draw dipole vectors toward the more electronegative atom. And so that means then due to the shape, right, if we drew it this way, they would cancel out. But due to the shape, there is a side of the molecule that has more electron density down here, partial negative. So that means, and partial positive up here, right? So that means then that is nitrite a polar molecule?
Yes.
Yes. Polar.
So then for the which intermolecular forces holds it together? Or no, that's actually a credit question. Never mind. I was looking at the wrong question.
Okay. That's good. So carbon dioxide, so I gotta get going, I've gotta get working, but carbon dioxide, do you have the Lewis structure for carbon dioxide?
4, 12, 16.
So I'm gonna leave, so David and Kelsey, you can see each other's, right?
Yeah.
Cool, so do you agree?
I think I did mine too. So I
Want to
got
show each other?
yeah, I got that, but oh, and I have to make the octet. I forgot the octet. That's what I was missing.
Let me see, here's David. Yes, 2 lone pairs on each oxygen, yep.
Yeah.
Yeah. I just forgot the octet.
Don't forget your octets, I'm noticing a pattern, be careful there.
Yeah, I know.
That's okay.
I always double check though, so
Okay.
go through my rules. So
Make sure
yeah.
you're double checking. Okay, good. So that's the Lewis structure.
So would it be a linear?
It is linear.
Okay.
Right,
And that's its molecular and electron geometry.
Right,
Okay.
that's the molecular and electron. So whenever there's no lone pair on the central atom, molecular and electron geometry are the same because there's no electrons to change the shape.
Okay.
Right? Over here, there's a lone pair on the nitrogen, so that means that the electron density, which includes that lone pair, is the electron geometry. So that means the electron geometry is going to be different because it includes the lone pair. So it's going to be different from the molecular geometry, which doesn't include the lone pair.
Mm-hmm.
You
Okay.
know? Over here, though, for molecular and electron, it's the same because there's no lone pair that changes things. Linear, electron geometry is linear. Now the question is, can we draw dipole vectors here? Are there polar bonds in carbon dioxide?
Yes.
Mm-hmm. And we're looking at our chart,
Mm-hmm.
right? Carbon is 2.5, oxygen is 3.5, so for sure we've got polar bonds facing at which elements?
Oxygen.
Oxygen.
Yep, toward the oxygen. And so now, do these polar vectors cancel?
Yes.
What do you think, David? Do they cancel? Are they going in equal and opposite directions?
I think they cancel.
They do cancel. And what I was showing people in the last open hour was like, think of it like this, where like, so over on this one for the nitrite, if I've got like two polar vectors, they kind of like add up and go together, right? Whereas if I'm linear, right, for carbon dioxide, oh wait, well, I'm going the other way. Well, if I'm like going like this, right, and I'm pulling like toward the oxygen, so I'm pulling out here, they're canceling out. I'm not like, you know, adding up. So I don't have more electron density on one side of the molecule than the other side. Whereas here, they add up together and have an overall electron density separation. But here, right, cancel. So this is nonpolar.
Mm-hmm.
Okay, so that'll give you good direction for the quiz. So tomorrow's quiz.
Is it tomorrow?
It's Thursday.
Sorry.
Thursday, okay. And
Okay.
the same time, 11:15.
Yeah, unless you have a combination. So Kelsey, I'm gonna start you earlier somehow.
Okay, I'll look out for it before class. I always do anyways. So I'll just look out for it and I'm assuming I'll take it a little bit before 11:15.
Okay, so I'll let people know too who other people have accommodations. So just like normally, you want to go early.
Okay.
Okay.
Thank you so much, Elizabeth.
Thank you both. Thank you so much.
Thank you.
And Lily, thank you too. Awesome. And great. I'll see you soon. See you Thursday.
Thank you.
Okay,
Bye.
you're welcome. Or tomorrow. Okay, bye.